Alright, hi everyone. Let's continue with our data structures and algorithm series. In our previous videos, we discussed about searching algorithms, right? Like linear search and binary search. And in today's video, we are going to discuss about another important topic, and that is sorting algorithms. Sorting is a process of arranging elements in a collection in a specific order, like ascending or descending, based on the requirement. For an example, let's say you are given an array of integers and you are asked to arrange the elements of this array into ascending order. As you can see in this example, we have 9, 1, 4, 10, 0, 5, 8. That's a random order, right? If we have to make it ascending order, it will look something like this, going from 0 to 10. And if let's say you are given an array of strings like YouTube, decipher, coding, in that case, you will rearrange these strings to look something like coding, decipher, YouTube, right? Because C comes first, D comes second, and Y comes in the last. Same thing goes if you are having an array of objects and you are asked to rearrange these objects based on the value of one of their properties, like sorting students' records based on their marks, right? And this is their descending order, like the maximum mark student comes first and the lowest comes to the last. This is called sorting. Now we have multiple sorting algorithms like bubble sort, insertion sort, selection sort, merge sort, and so on. All these sorting algorithms has their own pros and cons, but that will be based on the requirement and the data you have on which you want to perform the sorting. To see how these sorting algorithms will perform, we have a very amazing sorting algorithm animations. I will paste the link for this in description. As you can see on this page, we are having multiple sorting algorithms like insertion, selection, bubble, shell, etc. Also we have data like random data or nearly sorted data, reversed, and few unique. Now if you just want to play around and want to see which sorting algorithm will perform better in different scenarios, you can click on the play button and you can compare which one will sort the data faster. As you can see, in case of random data, selection sort was very slow. So yeah, you can just play around this data and see which sorting algorithm will perform the best with certain type of data. Coming back to the slides. So the first sorting algorithm we are going to look at is bubble sort. It is a sorting algorithm where largest value bubble up to top. Basically, if you are sorting elements in ascending order, then the largest value will move to the end first, and then the second largest value, third largest value, and so on. Let's try to understand this with an example. Let's say we have an array of integers 29, 10, 14, 37, and 19, and these are their respective indexes. So the first step will be compare your 0th index with the first index and see if the 0th index value is greater than first index or not. And after comparison, if we see the first element is greater than the second one, we will swap them. And then we will try to compare the first index with our second index and see if first index is greater than the second index, and then we will again swap them. We will do the same process until we reach the end of our array. If you see here, the second index value is not greater than the third index value. In this case, we are not going to perform any swap. We will keep it as it is. Now we will compare the third index with our fourth index and see if third index is greater than fourth index or not. If third index is greater, then swap them. And in this manner, you can see the largest value is now at the last index. Basically, the largest value bubbled up to the top. And now we will do the same process again, comparing the two elements again and again until we get our second largest value at the last second index. And in this way, bubble sort helps us in sorting the given data. Alright, now let's try to implement bubble sort in JavaScript. For that, let's jump onto the code sandbox. Alright, so if you remember, we need to iterate over our given array. For that, we will need a for loop. For let I equals to 0, I should be smaller than array.length. With every iteration, we will increase 1. And now, as you know, we need to compare two elements. For that we will need another for loop. For let j equals to 0, j will be again smaller than array dot length, and then j plus plus. Now here comes our comparison. If array j is greater than array j plus 1, then we will swap the elements. For that we will need a variable temp. In temp we will store the value of array j, and then we will replace the value of array j with array j plus 1, and then in the end we will replace the value of array j plus 1 with temp. That's a very common way to swap the values of two different indexes. Alright, I think that's all what we need to sort our given array using bubble sort. In the end we will simply return the array to see the output. Now let's try to run this code and see if we are getting the expected output or not. And see, we are getting the expected output. Our given array is now sorted. But this is not the optimized code. Why? Let's see. If I console log here, what are we comparing? Array j plus 1. Then you will see there are multiple comparisons that are not expected. Like we are trying to compare 37 with undefined. Why undefined? Because as you can see we are having j plus 1 here. J plus 1 might be going outside of this array, because if let's say the value of j is 4, which is the last index, then j plus 1 will be 5, which does not exist, right? Also, this code keeps on comparing the elements and keeps on iterating even when if it is not required. To understand that, I will put a console log here. Alright, so if you see, 37 was already sorted, but still this code is comparing 29 with 37 again, which was already done in the previous iteration, right? Same happens here. If you see, 29 was already sorted and compared with 19, but in the next iteration it is still comparing 19 with 29, which is unnecessary. So let's try to optimize this code and improve the time complexity by reducing the number of operations. To fix this undefined comparison, we need to change our approach of iteration. Currently you can see we get no idea whenever we are reaching out of the limit. We are just iterating for n number of times, and n is the length of our array, right? So we need to change our approach. Another approach is we will start with let I is equals to array dot length, and I should be greater than 0, and every time we will do a decrement here. So now you can see we are starting from the end of our array, not from the beginning, right? Let me just close this preview tab. We will reopen it later on. Now why we are using this approach? So during our comparison we will at least know we don't need to exceed the length of our array. So I will put here j should be smaller than I minus 1, right? Let's try to understand this in this way. If your length is 5, then j will run until j is smaller than 4, right? That is our j minus 1. 4 is the last index, right? 0, 1, 2, 3 and 4, which means this j will never reach at this point, but j plus 1 will access this one, and there will be no way of accessing index out of this array. We can remove the issue of comparing undefined elements. Let's double check this in our console. Alright, so if you see, we are not getting the undefined comparison anymore, and also the unnecessary comparisons are not there, because if you see, 29 was sorted already, so we didn't touch the 29 again here. Now if we let's say have a nearly sorted array, which is something like 1, 2, 4, 5, 7, 8, I will just fix it. Now if you see, once we reach at this point, comparing 14 with 19, there are no swaps, but it still tries to iterate over the rest of the elements, which is already sorted, right? Now this is unnecessary comparison. How can we stop it? We can put another variable, that no swaps, and every time we are starting an iteration, let me just make it no swap, not no swap. So no swaps, make it true. Once we find a swapping, we will mark it as false. And then if after completing one iteration we find out there are no swaps, then we will simply break the loop. And that's all. If you see now, my iteration was stopped at the comparison of 14 and 19. We are not comparing 1, 2, 4, 5, 7 again because it's already sorted. And that's all. I will just remove this console logs. And this is our bubble sort. Thanks for watching.